You resign from the job. So, our lesson today is on sequences and series in general. Not specifically a particular type, but a general sense of sequences and series. A sequence is a set of ordered numbers. There's a reason, a math reason to get the next number, the next number, the next number. Could be adding, multiplying, could be exponential, could be a bunch of things. But here's an example. A finite sequence means there's a limited number of terms. And here's an example, 3, 5, 7, 9, 11. Now, an infinite sequence has an unlimited, if I can spell that, an unlimited. And obviously you can tell when something's unlimited with the ... at the end and so on. It represents to infinity and beyond. Yes. So, since I know my son will not be watching any of these videos ever, I got him a Buzz Lightyear thing for Christmas, because that's what he wanted. Buzz Lightyear doll that says Space Ranger. You know what Buzz says. To infinity and beyond. You know what Buzz says. Yes, Space Ranger. He will never do that, ever. He could be my student and he'll refuse to hear his dad's voice during the day and night. No way.
You said your son?
Yes. Yes. My twin is a boy and a girl. And I have 2 other daughters after that. So, I know, right? And I find time to teach. So, now, the first term in a sequence is denoted this way. Now, this is called a subscript. A subscript would mean you write down A and then the 1 is just like a little bit below the A. That's called subscript. So, A1, not the steak sauce, is the symbol used for the first term. I know you've seen that before. Now, each subsequent term, we can write down A, and then you add 1 to whatever that first one is. So, generically, you could put down n plus 1 to represent where n plus 1 is the term number in the sequence. So, if you're given this sequence, can you identify the following terms? So, A1 is the first term. That would obviously be what number? 2. A5. Fifth term, and that number would be? 14. It's going to get more fun. 8th term. Hey, I don't see an 8th term. That means you got to figure it out. What math reason is being used to find the next term, the next term, the next term? Think about it. Write it down. Are we on track? Kaylin, are you on track? Let's do this. What is the 8th term following the pattern? Excellent. And then which one are we looking at? Rosie. Tell me, I love that you're speaking math right there. What reason, Rosie, are we using to find every term? What math are we doing?
Well, I just, from given this, the difference between those numbers is 3, and from whatever difference is from 8 and 814, I find the difference of that and then I multiply.
See, I like that, but how about just add 3 and then get the answer? Add 3, add 3, add 3, add 3, add 3, yay? Or that, whatever. It's like, are you just adding 3 every time until you get the number you need? Yay! Let's go up to 14. Use your fingers. I don't care. You already know the 8th term. Can you get up? Go, 9, 10, 11. Add. Use your fingers. Whatever. Can we get to the 14th term? I heard it. 41. Some might even recognize that's called what's called an arithmetic sequence. Or you could call it arithmetic if you're lazy about saying how you say it. So, an arithmetic series, right? Okay, since each term value is paired with exactly one term number, a sequence is a function with the following properties. The domain is the set of all term numbers. So, the first term, the second term, the third term, the fourth term, the fifth term, that's the domain. That's what you input. Not the actual numbers that you actually see. The numbers you actually see is called the range. So when you say the first term, you don't necessarily see the number 1, right? Whatever the answer is actually your range. In an infinite set, the domain is the set of natural numbers. This is actually down here. Natural, do you know what natural means? In mathematically? This should actually say term values. Natural numbers. Natural numbers are your counting numbers. So when you were a little thing and you learned how to count, what numbers did you learn? And you counted. You went 1, 2, 3, 4, 5. Those are called natural numbers. No one naturally starts counting with 0. No one naturally goes to negative numbers. No one naturally says 1.1, 1.3, 1.5. Unless you're with me, then when my kid says pick a number between 1 and 5, then you go 2.893. And they go, what?
I picked 2.5.
There you go. Right? Just a mess, right? All right. Recursive. Have you heard that word before? Recursive, the core word for recursive is recurring. A rule in which one or more previous terms are used to generate the next term. So one way to understand a sequence is just understanding the term before it. So what do you do with the term before to get the next one? If we only need the term before it, then that's what we'll use a recursive formula, where we need the one before to get the one we're looking for. So in this sequence, A1, the first term is 0, the second term is 1, then for each subsequent term, oh, Fibonacci. Let's go back up here. Do you know that guy? He's an Italian mathematician. Fibonacci. Now, Fibonacci. I know. Fibonacci is an Italian mathematician who saw in nature a pattern that occurs, and it occurs like in flowers and other things like that, that you'll see this pattern, and we could Google it, Fibonacci sequence in nature, and you can see cool pictures. What you do is you take the term before and you add it. So you have to start with 0 and 1, because then you have nothing to add together. But then what's 0 plus 1? 1. What's 1 plus 1? And what's 1 plus 2? 2 plus 3? 3 plus 5? 5 plus 8? Do you get the idea? You're just adding the number before it to get the next number. But you have to start with 0 and 1, so you need 2 terms to start with, or else it wouldn't work. This sequence, in terms of how like a flower grows, like 1 petal, then another petal, then 2, then so on, that occurs a lot in nature in terms of how something grows. So in this sequence, A1 is 0, the second term is 1. Then for each subsequent term, what do? Is you add the term before to the term. So how many terms do you need to add together to get the next one? All right, with this information, can you give the first 5 terms of each sequence? So number 1, what's the first term? 25. What does it ask for you to do each time to get the next term? Take that term and do what? Subtract 7. So the next one would be 18, then 11, then 4, then try the next one. What do we start with? And then what do I need to do? So a, n subtract 1 is the term before it. So what do I do to negative 2 to get the next term? You multiply it times, and then? So 3 times negative 2 plus 1. Okay, keep going. Find the next 3. The same pattern. Again, what am I going to do? Times 3, and then add 1. You can do it. Just choose to do it. Find the next 3 terms. Did you get negative 14? You can do this. 3 times 14. Negative 42 plus 1. You could even do this one. 41 times 3. You don't know what 3 times 1 is or 3 times 4? Negative 123 plus 1. Negative 122, right? Turn the page. All right, I want you to practice using math to find the next number in the sequence. So, try number 3. Can you write down the first 5 terms? Go. I need to see if you're still in Thanksgiving mode or if you're actually like trying to do some math. And for the most part, I'm going to allow you to use your calculator for this unit. But I don't want you to just go there because you don't want to think. Like if you need it, you need it. So please bring your calculator every day. And of course, tomorrow you're going to have a quiz on this lesson. Do you understand sequences and series? So, I see 1/2. What this is telling you is, can you take half the number? What's half the number? 20. And then add what that number was. So what's 20 plus what? 40. What's that number?
How many terms do we need?
5. So, when you see a, n minus 1, that's the term before. So when you see this, what term do we have before? So half of 40 is, and then you add that same number. So 20 plus 40 is 60. Can you follow a pattern or not? Next. What am I going to do with 60? Half of 60. Then add 60 to it. 90. It's always the term before. So, sorry, we started with 40, then the next one was 60. Did you get the next one to be 90? Keep going. 2 more. Now listen. I need to know where it's happening.
Half of 60 is 30, 30 plus 40.
Don't go 40. It's the term before it. So, to find 60, we use what? 40. But to find 90, we use then the next number, right? To do it. So half of 60 is 30, and then add 60 to it there. You get 90. Half of 90. Half of 90. And then add 90. I know this one's tricky. Half of 135. And then add 135 to it. All right, let's see if we can try it. Let's be better. Number 4, just want you to think. Can you write down the first 5 terms? So they do give you A1 and A2. In this one, how many terms do you need to find the next one? 2 of them. Which one goes on top? Which one goes on the bottom?
The first term.
So 8 and 10. Then the term I'm looking for, right? That's right here. Yes? N minus 1 is the one right before it. N minus 2 is how many terms before it?
2.
So it's 10 over 8. You don't have to reduce it down. But I just want you to understand the concept of N minus 1 compared to N minus 2. So this is the term I'm looking for. N minus 1 means 1 term back. N minus 2 means 2 terms back, and I use them and divide. So this one, what's N minus 1?
10 over 8.
10 over 8. What's N minus 2? And what do I do with those numbers? Just do it. Pretend that you can divide fractions. 10 over 8, how do you divide fractions? Times the reciprocal. And guess what? The 10s do something.
Cancel.
So let's pretend that when you go 10 over 8 divided by 10, it's times the reciprocal. What happens to the 10s? That's a good reason not to simplify it, right? Only simplify it if it makes it better, not just because you feel like doing it. Okay, now what do I do? 1/8 divided by, we know dividing fractions is times the, go for it. Yes, and what does it leave you with? 1 over 10. Because you got 1 over 8 times, right? 1 over 8 times 8 over 10. And it leaves you with number 5. Number 5, we're going to do something a little different. Thank you. All right. Now, shh, I need your attention. You're making it difficult today, listening wise. I need to write a formula. That was 2 eyebrow right? Not one did you, but twice you raised your eyebrows. I wasn't even looking at Jocelyn. I know. I think, how many is he going to do? 2, 3, 4? You did 2, right? Or 3? 3 eyebrow raises. All right. Here we go. Number 5. I want to write a rule. So, can you write down and tell me what's the first term? 9. What am I doing with 9 to get the next term? And then the next one. And then the next one. What math am I using? Adding something? What am I adding? So the formula is going to be AN, and you take what and do what with it? You take the term before it. Now, how do I generically write the term before? Remember up here? A, n minus 1, and then what am I doing with the term before it? Adding 4. This is called a recursive formula. The other type of formula is called an explicit formula. This is recursive, meaning I have to know the term before it to get the term that you're looking for. An explicit one is you don't need that. If I want to find the 100th term, I have a formula, I plug in 100 and get my answer. That's explicit. This is recursive. Again, what would the formula be? What am I doing to get the next, the next, the next? I'll let you look at it first. Can you see the pattern? I'm listening. Oh, and find the 8th term. All right, I'll do that in a second. I'll come back. Can you think of the formula? Anyone see a pattern? I'll tell you, it's not as simple as you just add 3 every time, or you multiply times 4 to get the answer. You want a hint?
Yeah.
You have to add 2 terms together and do something. So in other words, I got to add 1 plus 3, and then follow that pattern. What would you do next? 3 plus 8, and then times 2. 8 plus 22. You add, and then double. Add, double. Do you see it?
Yeah.
So, in this situation, I am adding. Now, which 2 terms am I adding? And how do I write it down to show the 2 terms before it? So I did both of them. N minus 1 is 1 term before. N minus 2 is 2 terms before. We add them, and then what do I do with it?
Multiply
By 2. That's the formula. Now I'll go back and find the 8th term. You're going to have to do some work for me. And you can use your calculator. 6 plus 22. Double it. There is no explicit way to get the answer. Meaning you got to find each term as you go along. There's not like one, boop, there's the answer. You're going to have to work to the end to 8th term. So, did you add them together and double it? Now which 2 numbers are you adding together? And you can use your calculator. You add them together and that's 224. If you double it, 448. We're at what? 7 terms. 1 more. Can you add them together and double it? You can use your calculator. If you add them together and double it, you get 1,224. Let's go back to this one. What's the 8th term in this one? What did we just do? Add 4 every time. That's a lot easier. See if you can find the 8th term. 29, 33. We're almost there. 37? I agree. 37. Hey, we just talked about this. What's an explicit formula? This is more powerful because I don't need all the terms before it. I can just plug in and get whatever term I'm looking for. So a rule in which the nth term is defined as a function or an equation. And for this function, it's not going to be the letter x, but the variable n. Not x, but n. So, if you look at the examples, they actually give you the explicit formula. If I want to find the first 5 terms, what number do I plug in for n? Or for the first term, what number would you plug in for n? 1. So 5 times 1 plus 1 is 6. How would you find the next one? What number would you plug in? 2. 5 times 2 plus 1. I know, the lighting's bad. I wish I could be God and change the lighting this morning. This is the worst of the period. I can't do anything with the lighting of it. For some reason. Is that better? Okay. How do I find the third term? What number do I plug in? Get the idea? 3, then 4, then 5. So let me write it down and I'll show you. So that's 16. The 4th term would be 21, and the 5th term would be. So for each one, can you follow the formula to find the first 5 terms. And these are all explicit formulas. That means if I wanted to find the 100th term, I would just plug in 100. I didn't need to know all the terms before it. I can just plug in and get the term I'm looking for. Here, the first 5. A1. 1 take away 1. 3 halves to the 0. Yay. Thank you for not saying the other answer. 3 take away 2. Or 2 take away 1, I mean. 1. And 3 halves to the 1 is? 3 halves. Plug in 3. 3 take away 1 is? 2. Can you square a fraction? And you get 9 over 4. 4 take away 1. Can you cube a fraction? Just cube each one. 3 cubed and 2 cubed. And one more time. 5. That's to the 4. 3 to the 4. You did these. 3 times 3 times 3 times 3 times 3. 81. And then 2 to the 4. So it's 81 over 16. Okay, number 9. Can you follow the rule? So, to find the first term, what number do I plug in for n? So 1 take away 1 is, divided by I don't care is 0. Plug in 2. This one I'll have to care more. 2 take away 1. And 2 plus 2. Again, I don't care if you simplify it unless it makes the answer better. 3. 2 over 5. Okay, 2 more times. The fourth term. 3 over 6. That's fine. I don't need to reduce it down. 5. 4 over 7. Beautiful. Okay, try number 10. Now I'm just going to write down the terms. Like I'm just going to do it in my head. So how do I find the first term? What do I do? Plug in 1. What's your answer? Then what do I plug in? Okay, go. I think this makes the answer better. 3 times 3 is 9. The square root of 9 is, I think that's a better answer than the square root of 9. Keep going. I'm happy. I know you could simplify it, but root 12 and 2 root 3 are equally beautiful. One more time. What would the next one be? All right, try number 11. Can you follow an explicit formula to find the first 5 terms? So if I plug in 1 take away 1 is 0, and then 1 cubed is 1, so put it all together, and what answer do you get? 1. Now try the next one. Challenge yourself mentally. Can you plug it in and do the math mentally to challenge yourself? Without writing it down, do you see 8 take away 1? That answer is 7. Keep going. Challenge yourself. 3. Can you hold 2 numbers in your head at the same time without writing it down? And subtract it. Bet you can. So 27 take away 4. Keep going. Plug in 4. 4 cubed. 64. 4 take away 1. Square it. 9. 64 take away 9. One more time. Plug in 5. 5 cubed is 125. 5 take away 1. Squared. So 125 take away 16. In your head. Oh, hey. Have you ever seen this before?
Yes.
Now, listen to me. This does not mean that N is excited. Isn't that cute? In math, I'm going to teach you something you may not know. In math, this symbol means a factorial. Have you ever done that symbol in math before? No. Well, you're lucky because you get to learn today. So, a factorial means that whatever number you're given beside that symbol, you multiply counting down until you get to the number 1. So in other words, if it was 3 factorial, you would go 3 times 2 times 1 and end there. That's what a factorial means. If it was 4 factorial, what would you do? I hope you're listening. 4 times 3 times 2 times 1. If it was 10 factorial, 10 times 9 times 8 times 7 times 6 times 5 4 all the way to 1. Yes? So, that's what a factorial is. You can fight it or don't fight it or hate it or love it. I don't care. That's what the math symbol means. Whatever the number is, you multiply counting down until you get to 1. Okay, so now that we know that, if I want to know the first term, I plug in 1. Now 1 factorial, there's nothing to count down from. So the answer is just 1. And 1 take away 4 is, maybe in Stats AP. You will if you haven't. Talked about a factorial? Well, you will. So, it'll come. Now you're like, oh, I totally know that symbol. So, 2 is 2 times 1, which is 2. And then 2 take away 4 is, here we go, 3 factorial. What is it again? 3 times 2 times, which is, oh, and 6 take away 4 is, nearly all calculators have that symbol on it somewhere. So if you ever see a calculator and you see, oh, that looks like an exclamation, that's not. It's a factorial symbol. All right, keep going. 4 factorial. 4 times 3 times 1. Can we do that? 4 times 3 is times 2. 4 times 3 is 12. 12 times 2 is 24. And 24 times 1 is 24. 24 take away 4 is? Okay, we're going to do it again. Here we go. You ready? 5 factorial. 5 times 4, 20 times 3, 60 times 2. And then 1, right? 120. Take away 4. Done. Hey, I learned something new today. Did you? Or maybe you didn't learn it. So, hey, 13. I want you to write down the rule to that sequence. So we're going to start with AN. I want you to look at it carefully, and I want you to think, what math rule is being used to find the next term? I'll give you a moment. Try to focus. Those numbers should feel familiar. Those numbers are called perfect something. Oh, you mean the rule is I just take the number and square it? That's silly. Like 1 squared, 2 squared, 3 squared, 4 squared. Did you see that pattern? I hope you study. Okay, 14. Look at it. Find the rule. I bet you know what's happening. I just wonder if you can think what the rule is going to be. So let's say you can see you're adding 2 every time, right? The answer is not n plus 2. And we're not doing a recursive formula. I need an explicit formula. Do you know what we call this type of sequence? This sequence is called an arithmetic one, because you're adding all the time. That common difference is actually the same as the slope of a line. So when you think of something explicit, think of a linear equation, like mx plus b. So the slope is going to be what number? The slope is going to be what number? So if I'm adding 2 every time, it's like going up 2 and over 1 every time, like the slope. I just need to add a number so it fits my sequence. In other words, when I plug in 1, the answer is 9. When I plug in 1, the answer is 9. I know, whatever. What should I add to it so it fits? So if I plug in 1, what's the answer? If I plug in 2, what's the answer? Does that formula fit? mx plus b. Our next lesson is going to be on arithmetic and linear in that connection, right? To be able to see the connection. All right, we only got 2 left. Oh, why did I put down n? Because I said mx plus b. Thank you, Rosie. N. 2n plus 7. Oh, we got to figure out what? So once we have that, what are you going to do? So to figure out the 25th term, you just plug in 25. That's the hard part is the formula. The nice part is you just plug in whatever you're looking for. Now you should know 25 squared, but if you don't, it is what it is. How about the 25th term here? So the easy part was to find the term. The challenging part was the formula. 15. Can you write explicit and recursive? For 15, what am I doing each time? Shh. You're adding 3. How am I going to write down the explicit if you're adding 3 every time? That means the slope is 3 up 3 over 1. What should I add or subtract so that it fits? So if I go 3n plus 1, does it fit? And then you can test it, right, to make sure when you plug in it gives you the answer you're looking for. Recursive is always easier. What's the recursive? You take the term before, and what do you add to it? That's it. Do you see how much easier the recursive is? You just need to remember what's the symbol for the term before. What do I write that down, right? So you take the term before, and what do? Add 3. That's easy. What makes this one challenging? What's the 100th term? Well, that's right? You need the explicit, right? Makes it easy. All right, try number 16, and then you got work to do. Do you know the math rule for this pattern? Let's start with the math rule and then think how we're going to do it. What math rule are you doing to get the next term and the next one and the next one? Do you think you're adding 1/2 every time? Okay, now write that as a formula. So the recursive, super easy. What would you do with the recursive? Take the term before it, and what do? How about for the explicit? You have to think a little bit more. What's the slope? So each time you're going up 1 over 2, 1/2. What do I need to add or subtract so it fits my sequence? So when I plug in 1, the answer is 1/2. When I plug in 2, the answer is 1. And the answer would be you'd have to add 0 or nothing, right? It's good the way it is. When you plug in 1, it fits. All right, there's your lesson on sequences.